So I want to get started on making molecules because that's the two things that are in this chapters. One is to figure out how to make a correct molecule. Okay. You are being recorded. You have been warned. And we are going to start out by using our cards. And yesterday we were making squares. Today we're making molecules, but it's pretty much the same stuff. Never mind. I'll put this over to the side. You guys can see okay, right? It not move so you can. So you will need loose leaf because this is, I went through the notes. There's an answer key. It will be posted. I scanned it, but I got it done last night. That was interesting. That's probably close enough. Wow, it's been a while since I've done this. Okay, so we're talking about molecules today, and like an atom, they have to be electrically neutral. But we don't have to count all the little molecules, or sorry, all the little electrons. All we need to worry about now balancing is the charges. So we're going to start out. We are going to mix beryllium and fluorine. So we're going to start pretty easy, and then we're going to get more complicated and more fun as time goes on.
Hey, Joanne, quick question. Did you want us to even take down these notes?
That would be clever. Yep, just on scrap paper is fine. So there's a number of ways that I'm going to be giving these to you. This is just a simple, I didn't make up a worksheet, so we'll do it together. Usually I'll start with the elements. So then you grab your pink ion sheet and you look them up. So you can see beryllium is right here, Be +2. I'm going to write that down. And can somebody find me fluorine?
It is. Is it fluoride?
Yes.
So it's 9.
All right. Yes. But okay, so one thing, the names are going to change. So when an atom becomes part of a molecule, its name might change. Always trust what's on this paper. So even though it says, I said fluorine here, fluoride is what you're looking for. Because you know where fluorine is on a regular table, and it's the same thing. Right now, I need to know it's F -1. There. So we need to take these together and make an electrically neutral particle, molecule. So there we go. There's my +2. There's a -1. Play along. Dusty, is that electrically neutral? Cuz? That's right. It's not a rectangle. We're missing a 1. Very good. Now it's electrically neutral. We got a nice square. Thumbs up. Nina, how's your volume? Is it working? I can yell.
But where did the other -1 come from?
There's a lot of them hanging out. So when you do these, you can have an unlimited number of +2s, an unlimited number of minus ones until you get your nice little rectangle. Okay, now when I
Mhm.
said that, and notice how they're interlocking here, so they'll stay together as a molecule. If I thought, well, hey, that was fun, and I decide to do you know what I've made? Anybody want to guess? Two molecules. This one and this one aren't stuck together. So the rule, it's always the smallest whole number ratio that you can make. So when we put these together, it took a beryllium and it took two fluorines. And that's how you'd write it. And that's why you write it like that. F2. I would say put your glasses on, just come closer.
Yeah, honestly.
Honestly, just come closer because I'm not 100% sure how to make this bigger here. It looks like it's only gonna let me share that a little bit. Okay. What we're also gonna do, we're gonna do a 2-for-1. So not only are we gonna learn how to make the molecules, we're gonna name it. Easiest, go back to your chart. See where it says beryllium? It still says beryllium. So we're gonna write beryllium. But where the fluorine is, it says fluoride. So this is beryllium fluoride. The general rule is the first part is always the positive particle, even if I try and trick you and put the negative one first. And its name doesn't change, but the negative ion does change. So fluorine changes over to fluoride. So when it ends in an IDE, you know it's a charged particle. So ta-da, we made beryllium fluoride. And before you ask, I have no idea what you use it for, other than science today.
Could I ask what you use that for?
Thank you.
When you have IE, that means it's had the charge. How does
Yep.
it do
Has a charge. So when fluorine is neutral, it's like this. When it's part of an atom, it ends in IDE. Oh, and I did miss one part. For what we're doing, we're always going to be combining a minus and a positive. If I have two positives or two negatives, I've probably made a mistake. Or I'm trying to trick you. I don't know. Excellent. Okay, let's do it again. Need something more interesting. Sodium. So number one, look up the symbols and the charges. Stacy, how about you? Can you tell me what the symbol and charge is for sodium?
My pink sheet is making me dyslexic.
Okay,
Oh, I found it.
there you go.
NA.
And it's
NA
plus one.
plus.
Nice. Oh, if your pink sheet is irritating you, there's also on the back. I find the front side easier because I know where elements are, but it's, if you can't find stuff, you can also look on the back. So there's sodium, Na plus.
Would it be nitrite?
Yes. Yep. So nitrite is there, and it's in the same spot in a regular periodic table as where nitrogen would be, but because it's an ion, they change the name. So it's N minus 3. Whoop. Or 3 minus, whatever. It doesn't, whatever makes you happy. That newfangled science sometimes confuses me. There we go. So then we get our little pieces out and we find a minus 3. And we need a 1. And I'm going to put it over there so we can see it. Nope, this way. And you make a rectangle again.
That's the one be positive or would, okay.
We got to match innies and outies, and we only have the choice of using plus ones. This, whoops. No. Not allowed to do that. What we're making are called binary. We're keeping it simple. Binary meaning how many? Dos, 2. So you only get to use the 2. You have to be able to make a nice little rectangle out of that. All
I'm
right.
glad you said that because I did grab a +2.
I know it's like, why should I fiddle around with 3 of those? The 2 fits perfectly. Yep. Sorry. Nope. Take organic chemistry. All rules go
Well,
south.
How
Sean,
come you got papers to doodle with, Stacy? I'm drawing mine handmade.
Don't lie, you're watching TikTok.
I'm just watching her. I'm not even gonna lie.
No, for real, I am, man. I didn't have no papers, so I was just drawing them.
good man,
Turn
Sean.
your camera on or it didn't happen.
Oh, she's calling you out now there, bucko.
No way.
No, man.
No.
This is
Turn
so
on your camera.
He won't even
different.
be at home.
This is so different from normally. Usually students don't want to talk. This is the unique class. So, hey, Sean, since you're there and you're drawing and you're working along with us, what should we write here as the actual formula for sodium plus nitrogen?
No comment.
How many sodiums? How many plus ones did I need?
3.
Yes. How many nitrogens did I need?
3.
Oh. 1.
Oh, 1. I only went with because it said -3 there. That's why.
Okay, that's okay. So notice when we do write the correct formulas, the charges, they all disappear and the numbers go down to the bottom. Okay. There will be some different ways I'll show you later, but right now we're going to keep building our models or drawing our models. Now we need, oh, question. Whoops.
The 3? Yeah.
Yes. Yes. I didn't even make that nice.
Show me the drawing.
3. There. That's pretty. That's perfect. Oh, there's
Oh
something
my
there.
God, it's beautiful.
Sean.
Good job, Sean.
Good job, Sean.
Okay. Now we need to name this. Jacob,
What's that?
when you look
You're getting put on the spot, buddy.
when you look up sodium in the little box, what does it say?
Na plus.
No, what word is
11.
underneath? No,
Sodium.
Sodium.
That'll look no.
sodium. Oh, I should just throw it out there. I tend to use capitals because I enjoy chemistry so much. I'm not
Why?
going to worry about it. Now, if we go under nitrogen, Jacob, it doesn't say nitrogen. It says something else. What does it say?
Nitride?
Nitride. Yes. So there we go. Sodium nitride. And that's the correct formula. Ta-da! And no, I still don't know what it does. Pretty cool. Sorry, it's as exciting as I can make it.
I'm having a lot of fun today.
Isn't this? And you know what? When you write your test on this section, if it makes you happy, you can have the little chippy cards. I don't care. That is okay. Or if it's a bad day and you forget them, or I forget to give them to you, draw pictures. Works like a charm.
Can I
Oh,
do
we're
this
gonna-
on at home on the computer?
Yeah, you could make me a nicer set and then cut them all out. We had a teaching assistant class in here once. That's why I have a whole bucket full of them cut out. They did all the negatives and then they got bored and they quit. So I have lots of yellow. All right, here's going to be a hard one.
Let's use technetium.
No, not yet. But I will put that on the burner as something that we really need to do.
Where's the
She's doing it because it's 43 and it's +7. Somebody's
Yeah.
feeling cheeky. All right.
Give her.
And you guys thought that we couldn't do this. Okay, Nina, get ready. No pressure. This is going to be for you because I've picked on everybody else.
Would that be Ga3 plus and arsenide As3 negative?
Perfect. All right. One of the things you can do as you're doing this, thank you, Nina, is have the other periodic table with you. Maybe the one that's got the alphabet on the alphabetical order one. Because if you look up gallium, you'd see it was number 31 and it might be easier. Or just become one with your periodic table. Now, where'd it go? How many chippies do we need? These are not chippies. 3 plus.
Can we use the big three or do
Three
we have
neg-
to use once again?
3 and 3? Oh,
Yeah. Whatever this is, those are the pieces. Wrong way. Those are the ones you get to use. That's why I'm choosing the specific pieces. So if it says +3, I only get to use +3 pieces. This is -3, I get to use -3 pieces. So Nina, show me your magic. What is the chemical formula for when I mix gallium and arsenic?
would it be Ga capital AS6
No, stop there. You're done.
or just a 3? Just like
Because
that?
we have one of these, that's it. This rule is the one that messes up people the most. Because there's all these 3s and I need to do something with, no, you don't. You're counting how many pieces you need. I need one of these, boom. Matchy, matchy. There's going to be no numbers on the bottom.
So if you only have one piece, you don't have to write one, you could just.
Correct. If you do this.
Oh, is that like just kind of canceling out the numbers there, like on the top?
Yep. If you do this, I'm marking it wrong. No ones in
The
there.
assumable one.
Yeah, and unlike math, I'll get in math you want to write X with a 1. I'm like, live it up, I could care less. In chemistry, yeah, no. Just no. Don't do it. Don't do it.
To change the formula?
No, you'll look like a fool.
What am I doing like?
And I can say this
Right.
because I'm a chemistry teacher. Yes, no, just don't. No one ever does. Yeah, and there's no reason to ever put ones. In math, there is because, you know, when we're multiplying, we add our exponents. Like there's all sorts of reasons I show you that. But for this, nope. Maybe the chemists are just smart enough to say, yeah, no, we know what that means. I'm sorry if I called someone a fool. That might have been you, Stacy. My bad.
No, no offense taken. Sometimes we fools.
See, I trust you guys, so we're good. Okay, are we
Like
happy?
Dusty.
Dusty, 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 are you happy? Okay. Let's see what else we can use. Let's
Okay, I'm
go
gonna
with,
be walking away real fast from my phone here. I have you connected to my AirPod here. I just gotta go
Alright.
upstairs and check my kids here.
all right. I think you guys are rocking this. And sulfur. Cesium.
Can I have a thing? Oh, no, I found it.
Yeah, get out the one, your old periodic table with the alphabetical one on the back. Yes, ma'am. Yep, yep, yep. You'll get used to that. So if it goes from something to ending in IDE, it's like, oh yeah, that's just the ion. All right, Dusty, I sensed there was a challenge. So can you do cesium and sulfur for me?
Can I do it?
Yes, please. Tell me what to write.
Pass it, Dusty.
Table 1. Plus 1.
So what's the symbol for cesium? Yeah, what letters? There we go. So, and sulfur? Yep, sulfide. Nope, not up there. Whoops,
Right hand side.
sulfide. No 8s or 8s today, only ides. So stay out of this middle section today. So it's S what? -2. Okay, so we're going to build this. So there's my -2. How many positive ones do I need, Dusty? Okay, I like your style. Okay, can you finish this? How am I going to write it? CS. How many did I need?
2.
2. How many sulfurs? Okay, not right in that part, but that's perfect. Now, if we look it up on the chart, cesium is cesium. Like I said, the first, whoopsies, the first part never changes. That I'm going to go with rarely because there'll be some weird example. And sulfur became what? Dusty, still picking on you.
Sulfide or something?
Sulfide.
Yeah.
Yeah. So we have to be careful. Sulfur is a bad one. And maybe I'll do it. I'm watching you guys look on this side. Okay, so this is the back of that chart I've been using. We have sulfur -2. So when I say sulfur, this is the one I'm talking about. But soon, not today, but soon, we're also going to be talking about sulfite and sulfates. So the back part becomes important. What I remember is it ends in IDE. It's just the element. If it's got an 8 or this is one 8 or 8 at the back, there's some oxygen thrown in there. I don't necessarily know how much, but I just know it's got some oxygen and just life becomes more complicated. Yeah? We're digging this?
I'm having the
Kyle, you're quiet. Good?
feel like this too.
Well,
Just following along.
following along, having a good time. All right, so let's make this a little more fun.
Hey, before you go any farther, what was that CS2 what? That's it. Never mind, got it.
Okay, cesium sulfide. Oh, you know what? We can up it a little bit. Let's take a look. Yeah. I gotta spell it right. Whoa, what? Well, okay, too late. I put oxide. That was supposed to be oxygen. But maybe I'll just give you the name. Yeah, okay, just so it's not confusing. Let's start like the way we were. There, that's what we've been writing. I challenge you all to, why is there a 3 after the nickel?
Is it because of the charges on them or?
Yes, because if you look up nickel, there's 2 possibilities. Nickel will form +2 or a +3 ion. These ones, this whole middle part is called transition metals. Oh, excuse me. And I kind of think of them as teenagers. Sometimes they act one way and sometimes they act another way. It's got to do with, okay. If we have just plain old boring nickel, how many protons does it have? Anybody?
28.
How many? It's got 28 protons. So if it's neutral, how many electrons does it have?
28.
28, right? But they can't be all squished in really, really close. Some of them are farther out, and some of the ones that are farther out are like, see ya. So they don't behave so well. So we get them in different forms. So when you see there's nickel 2 and nickel 3, we got some with copper, iron does it too, manganese does it too. Don't worry about it. It's quite beautiful now because if it says nickel 3, I don't have to look it up. I know it means nickel +3. And you finish it. Do, 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 do. You guys are all clever. Come on.
Can I do this?
No.
I don't like that.
No, I don't like that.
Can I just do this?
That's still different.
It's really different. Oh, can I just leave a bunch of ones?
No,
Dang,
Shelby's making up her own rules.
I can't get it.
Those are the only choices you have. Were you not listening yesterday when we did this?
My choices. That's not working.
Patience, grasshopper. Does anybody remember from yesterday when we were playing around what we did? I know you did it. All right.
Nino.
Nina, were you paying attention? Because apparently Shelby was not. I mean that in a nice way. All right. You're
Do
like,
you
I
just
got
add another -1?
no. Okay, add a -3.
Oh, like, no, she told me no.
No to that too.
No? Oh,
Do we add 3 negative
told me
ones?
negative?
No.
Nope, she told me no to that too. What? You didn't say that yet.
These are my only choices. I can only use +3s. So it's like I have a pile of these and I can only use these ones.
I did. Right?
I don't know. I think so. You were doing it yesterday. You had it figured out. And then we put another -2 and look at that. We made a rectangle. Ta-da! It's just a
Which
big
cost
rectangle. Yeah. But now comes the hard part. Nickel. How many?
2.
2. Oxygen.
3.
Nice. There we go. And you call it nickel. Oopsies, I spelled nickel. Ah. Yes. And we would call it nickel 3 oxide, which I wrote up at the beginning. So that's what it, hopefully, now it's cluing in when I talk about binary compounds. You only have 2 things to work with. You have the +3s, the -2s, figure it out. It should make a lovely little shape for you.
So
Yes.
if you have it like that and you need to add on some to make that a whole molecule, you can.
Yes. Because the way I look at it is like, okay, that's not enough. Oh, I'm just gonna add that. Then it's like, oh crap, that's not enough. Well, you just keep adding. And they all should be connected. But you can't, at this point, you can't put more on because then you're just going to start making a new molecule. It has to be connected because that means all the bonds are happy and it's happy. It's just happy. We can even, not that you have to. Oh, okay. Back into a close-up. All right, Kyle, how many positive charges do I have on those 2 nickels? Nice. Now we got oxygens, and I'm kind of like checking this. So I've got an O -2, an O -2, and I'm putting the other one up here, an O -2. Grand total, Kyle? So now we can see there's not going to be any net charge. Everything's matchy-matchy. This part, just a quick check. All right. I'm gonna come up with some more. I gotta figure out how to rate them this way, and then we can work down so I can put more than one up there.
Why is Sean on hold?
I don't know. I've never seen that before.
Maybe he took us to the bathroom.
Okay.
Ew.
Or he's on TikTok.
There's just no chill, I think is the word I'm looking for. Yep. And I figure out if I write them that way, then we can work down and you guys can do them all together. But you will. Thank you, though. No. No, 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 no.
About how bored.
+4.
Do you think you would just kind of keep building it up like that other one? That's the,
What?
you know, like the one where, oh, what was it? The last one that. Where do we find bromine? Bromine is 35. Bromide.
-1, right?
Oh, yeah, that's gonna be. -1.
Oh, I think my bad, maybe.
What?
Zirconium? What charge has it got?
Just had it.
What?
What?
Where am I?
Where?
Zirconium.
+4.
Hmm.
Then beryllium has a negative charge.
Well, that's
Bromide, sorry, bromide
Oh.
has a negative charge.
BR -1. Okay, so we got to build that. But wait, we don't have a +4. We do now. It's the only time you get to do that. Whoop. There we go.
Hey, you said you can't do that. You make a
I
new
know.
one.
I know. But I'm not making more of these silly little things because I don't enjoy cutting them out. But that is my solution when we don't have the appropriate numbers. Just turn them over and we get +4 that way. But you guys, I think, might even be on to a slick trick to figure this out. Sean, How many bromines do I need? To make it work?
I'm gonna say 4.
Yeah. And we're doing it with the little chippy things because you know what? For me, if I can physically do it and then I can physically start to imagine it in my brain, it's like, yeah, it just becomes simple. So zirconium. Then what, Sean? Whoops.
I'm
How
gonna
many
say BR4.
Nice. That is exactly right. And the bromine becomes what?
Wouldn't that change to bromide?
That is perfect.
Hey Nina, did she ask you? She said Sean.
Yeah, it's like you guys are right here. That's beautiful. That's really good. I have a question though. Up here, when I named it, I had to name it nickel 3 oxide. Do I need to call this zirconium 4 bromide? Anybody want to guess?
Yes.
I got a yes and I got a no. Shelby wants
I
to
say
say
no.
why it's a no. Why?
One piece.
Now,
Okay.
if you look at zirconium, there's only one form of it. So we don't have to say it's zirconium 4. It's just like zirconium. It's just like when we say dusty, we know it's dusty. Like there's no other, that's it. It's kind of like Cher or Bono.
Not like
When you say Dusty, Jacob looks though.
But if you look at nickel, see there's 2 different forms. So then you have to say which one you're dealing with. Basically, this pink sheet is a beautiful thing because you know what? If it's got the little number after the name, put it on. If it doesn't, then you don't need it. So this ion chart's, gonna make your life easier. Did I hear that Jacob wants to do the next one?
No, you did
Well,
not.
I'm gonna say you do.
All right, who has a kid in here?
Sorry.
That's okay.
Oh, is that Linda?
Linda.
I'm leaving you guys out of this. Jacob, your turn.
What's up?
What am I writing? What's the symbol for potassium in the charge?
I don't even got my ion sheet on me. I'm looking online for it right now.
I help you. It's K plus. And selenium, somebody in here? SE. -2. All right, now you got your ions. Now you can just do it. So here you go, Jacob. There's your -2.
Yeah.
Okay. Are we done?
No.
How many more?
One more.
One more. Okay. So now, how do we write that?
That, my friend, is a good question.
Well, my
K
friend.
plus 2?
Okay. How many of them did we need?
2.
Okay. And how many seleniums did we need?
-2.
Nope.
2?
One.
One.
There we go. So K2SE.
How come we don't put in SE1?
Because you don't write the ones at the bottom. It's a chemistry thing. We're cool that way.
Because you look like a fool.
Yeah, that one
Stacy?
kind of slipped out.
Oh, that's rude to say that to Jacob.
Yeah, that is. I would have come to your house, Stacy.
All right, kids. We're all good. Play nice. There are children listening, apparently. So play nice. All right, last one. Who's Kyla? I have not talked to you. Your turn. No?
So lithium.
Okay, what's lithium? I know the symbol is Li. What's the charge? Okay, what about iodine? Left, right hand. There it is. Okay. So we have +1. -1. Done. So what do I write, Kyla? Like that. Perfect. Deviate this up. And we don't say iodine, we say nice. Excellent. You guys are doing wicked awesome. All right. And now I'm going to see, I told you, and we've got a video now. And no, I'm not going to videotape all the time, but we got a video now. It makes life easier. All right. I want to do osmium. Wait, you look a box of papers.
Oh. And then.
Some of these you'll just get so good at, you'll have it all memorized. All right, so I don't have a -4. So I'm just going to cheat and make one. Whoops, sorry, +4. OS +4, O -2. Here's my osmium. And I need 1. And I need 2, and you already know this. Ta-da. There we go. In case you want to see all the chippies. So whose turn? Nina, it's your turn.
I'm
What's
so
my-
curious about carbon.
I know, but we have to do osmium first. Nina, can you tell me what to write so that we can do the fun stuff?
For carbon, for the one, it'd be OS O2.
Perfect. I really need you guys to remember this because I'm going to show you a shortcut later and you're all going to forget. So remember to be careful when they're multiples of one another. So we got 4s and 2s together, 3s and 6s. Just be careful. Okay. I'm not going to rebuild it. You know what it's like. Osmium. Anybody? Mm-hmm.
Osmium oxide.
Nice. You guys are spectacular. Now, what is wrong with carbon?
Carbon has no charge.
I know, but dig out your good old periodic tables, the white ones in the plastic sleevey. Oh. It was white and we colored on it.
Oh, +4?
Mm.
Plus or negative voter.
Right. So carbon, that's why they don't put it on the chart because it's too weird.
I
Well-
have to go switch my laundry, so keep talking, but I'll be back.
All right. So here's the scoop. I suspect in your life, if you're hanging out, say here, you're going to act one way. And some of you, not all of you, when you're hanging out with your friends, you're going to act a little different. Smile, because don't even I do.
Yes.
Hang out with the people I went to
Tell me.
school with, I have potty mouth. Because anyway, that's nothing to do with this. So with carbon, you figure out who he's hanging out with. So in this case, oxygen is -2. No,
Opposite.
because they need to go cancel. Right? We need to have pluses and minuses. So you check because carbon can be a positive or a negative, see what it mixes with, and you always make it the opposite so that they'll cancel out. Yeah, it would be +4 when it's mixed with oxygen.
With and with the opposite.
So when I'm hanging around my in-laws, I'm a very positive person and watch what I say. And I'm a good girl because they're just that kind of people.
Do opposite charge. And ready. Woo.
And I realize we're gonna get kind of a boring thing. What's the answer?
CO2.
Perhaps you've heard of CO2 before, carbon dioxide. Yeah. Lame. I feel the love.
That was fun.
Okay, so there's my carbon. It's my +4. And a -2. And another -2. And we get CO2. CO2. When we're naming it, I'm okay if you say carbon. Yep. Because that's what we've been doing. But when you want to impress me, you go, hey, I know about that. And we actually usually call it carbon dioxide. This is an exception to the rule. It's just a little bit weird. We'll do the now I would like you to do the carbon and the hydrogen. And then I'll show you something cool. So if we're mixing it with hydrogen, hydrogen's a plus. So carbon's going to act as a negative for it. So it's going to act as the opposite. Do. So our chemical formula is going to be CH. Anybody? 4. Okay. Now we're breaking some rules here, but that's what you normally know it as. Nobody calls it carbon. Well, if you look where hydrogen is a negative, we could call it hydride, except that's when it's a negative, but we had it as a positive. So we would actually call it hydrogen. Because if you remember, I said the positive part always goes first. Okay, now you are hearing me say it. The positive part always goes first, even when I sneaky put it in the back. And carbon becomes carbide. Like carbide drill bits, saws. Yes. But most of the time, yep, you just call it methane. Carbon is an amazing compound or amazing element. And when it gets into organic stuff, it just does whatever it wants. It has its own set of rules. So take organic chemistry. It'll blow your mind.
You saying that makes me super not want to take organic chemistry.
Let me put it this way. Organic chemistry was the one I probably struggled with the most. It was just a huge amount of memory. It was very cool, but it was a lot of memory work. Okay, I'm going to show you some magic. I don't copy this down. Just relax. Okay. Yeah, get yourself. We got to wait till Shelby gets her super special some kind of thing.
Okay.
I'm going to take you into, I think it's grade 12 chemistry, might be first year university. So we're going to digress because I need to show you this. We're going to get a whole new page. We're going to talk about carbon. And there is a point to this, but you have to be with me. Jacob, you still there? No. Of course, who's still there? We're taking a roll call again.
Here.
Thank you. See,
Here.
there we go. See, this is what happens. People disappear. Okay. How many protons does carbon have? Are you sure?
6.
Yeah, I'm just messing with you.
Holy, I'm going well.
And nope, Kyle is yawning. Kyle, where did those 6 protons hang out? Right. We're going to forget about charged particles for a minute. We are just going to look at plain old boring carbon. Now, to get some negatives, to get everything all balanced out. Dusty, where do the electrons hang out? Exactly. People are choking here as I look at them. This is not a good thing. What are those things called, Stacy, on the outside where the electrons hang out?
Where they hang out, like the orbital?
Yeah, the orbital. Okay, so now you're going to get the magic stuff. The orbitals exist. And we have a nice, I'm just going to draw them as circles because it's simpler. And this is called the 1s orbital. And I like it because it's the number 1 because it's closest to the molecule, to the nucleus. Huh? And it's S because it's spherical. God bless them for using stuff that makes sense. 1s. Okay. And this 1 is only big enough to throw 2 electrons in it. That's it. There's no more room. And if it has 2 electrons, what element has 2 electrons when in its neutral state? What has 2 electrons?
Helium?
Yes. Okay, that's super stable. But we need 6 in total. So we're going to throw in another orbital. And conveniently, it's another spherical one. What should we call it? It is the 2s orbital. All right. So now we've got 4 protons, but protons like to be paired up. So it's actually quite happy. It's not perfect, but it's fairly stable. How many protons are left? Jacob, are you there?
Yeah.
Okay, so we have 4. How many do we need in total? We need
Come
2
again?
more. We need 2 more. Okay, this is where it gets weird. Are you ready? Our p orbitals, whoopsies. Well, it was nice for a while. Now it's the p orbitals. They're shaped like a pair of pears. So much for the pretty spherical ones that made sense.
Your
Pretty
drawing's
much.
drunk.
If I was doing it actually correctly, one of those would be coming out of the page. So it's along the x-axis, the y-axis, and out of the page. But we got 2 up here. 2 more electrons. So it's the electrons on the outside that do the work. So sometimes carbon will actually form, now I got to get it right, a +2 ion, and it'll get rid of these. only. Normally it gets rid of 4, but it might just get rid of 2. And there's a point to this, because oxygen is what charge?
Positive.
So when we put those two together, Jacob, what are we going to write? A +2 and a -2.
Nothing.
I'm going to write CO with nothing on the bottom. Please tell me there's somebody in the audience right now that recognizes that. Carbon? What? No,
Carbon dioxide?
no. Wait a minute. We did carbon dioxide back here. That was CO2. The
Monoxide.
dioxide was because there are 2. What was that, Jacob?
Monoxide.
Nice. And that's one of the reasons that it has a bit of a weird name and we don't just say carbon oxide, because I don't know. If I say carbon oxide, if I just say oxide, I don't know if I'm talking about this one, CO2, or this one, CO. And CO2. So the di and the 2 and the mono and the understood 1. And there's a big difference. Carbon monoxide does what? It can kill you. Well, so can carbon dioxide, but carbon monoxide is worse for you. It's the one that'll get on your red blood cells and ride around so you can't have any oxygen. All right, so it is 2 o'clock. We are going to spend the rest of the afternoon working on math, but I'm going to sign off because we all know how to do math. It's just a time to get stuff done. Tomorrow's the exam. It's fairly straightforward.
All right, love you guys all. Have a good day.
All right, see you
Are we
guys.
not all
Before you
gonna
pass-
take our computers
We miss-
outside?
Can I go to that house for that picture?
Jacob's me.
Sure. Okay,
Joanne, before you leave,
yes.
I might be coming in, I don't know, tomorrow. I might be coming in the morning to grade my exam. If
Okay.
that's okay with you.
Yeah, we'll double check it with, maybe send an email to Brian, but it's fine with me. It's ready. You can write early if you need to.
Okay, yeah, because I have no babysitter. That's why Dusty's there, and I'm over here. And yeah,
So you'll have a
the
babysitter
plan.
tomorrow?
and in the morning I will. So and it's my wife goes back to work late in the afternoon.
Okay,
Well, we'll figure something out. I'll email you either this evening or first thing in the morning.
okay, sounds great.
All right.
And we're done. Bye.
Okay. Have a good day, bud.